Hi everybody, we are back again with some polynomial questions. Last time we had done some application of remainder theorem and factor theorem. Today let's see what exactly we have to do, what is the problem statement given to us. So this is what it says. If x square minus 1 is a factor of polynomial this ax raised to the power 4 bx cubed plus cx square plus dx plus e, then we have to prove that a plus c plus e is equal to b plus d, which is equal to 0. Okay, what do we have to prove? Given x square minus 1 is a factor of the polynomial px, assume this is px, we have to show that a plus c plus e is equal to b plus d equals 0. Okay? Let's start. What do we see? What do you understand when they say that x square minus 1 is a factor of this polynomial, of the given polynomial? What do you understand from x square minus 1 is a factor? That means, you see, x square minus 1 is something like, it should hit you. X square minus 1 is a square minus b square, something similar to that. The formula x square minus y square, a square minus b square, which boils down to x minus a, x minus b. Right? Sorry for that. Let's just quickly go back to this. What is the formula of x square minus y square? It says x plus y, x minus y. That's what we know. That's the basic formula. Right? X square minus y square is x plus y, x minus y. So, extending it to x square minus 1, what do I get? This is x square minus 1 square, which will be x plus y and x minus y. So this can be written as x plus 1 and x minus 1. Following the formula, x square minus y square is x plus y, x minus y. Okay? So we have to remember this. So what is given to us? X plus 1 and x minus 1 is a factor of this polynomial. So, next what do we have to apply? Factor theorem. Because we've been told about the factors. We know that both of these are factors of this polynomial. Therefore, since both x plus 1 and x minus 1 are factors to the polynomial px. Okay, let us write this polynomial. Let px be ax4 plus bx cube plus cx square plus dx plus e. Let px be the given polynomial. Now, we know that x plus 1 and x minus 1 are both factors of this. Why? We just explained. We just opened up x square minus 1 by the formula x square minus y square. So if x plus 1 and x minus 1 are factors of this given polynomial, now what is the next thing we apply? Factor theorem. That is, my p1 will be 0 and p minus 1 will also be 0. Right? Because from here I get 1 is a factor, sorry, not factor, x minus 1 is a factor, and hence p1 has to be 0. From here we find x plus 1 is a factor, which means x minus of minus 1 is a factor, and therefore p minus 1 is also 0. The moment I get into this, half my problem is solved. All I need to do is substitute 1 and minus 1 in the given polynomial px and see what I can get from there. Okay? So let's see. What is P1 is equal to 0? What it leads to? What does this lead to? P1 will be A 1 raised to the power 4, B 1 raised to the power 3, C 1 raised to the power 2, D 1 and E, which is equal to 0 because of factor theorem, because as I said, I'm sure you must have understood by now. So this is A plus B plus C plus D plus E is equal to 0. This is one equation which I get from here. Okay? So what I understand is sum of A plus B plus C plus D plus E is 0. Okay? Which I can also write as by simply regrouping, as we had studied associativity rules in younger classes. A plus C plus E plus B plus D equals 0. Can I write this equation like this? It just says the sum of all these variables or values sum up to 0. So all I did is just regroup. Due to the property of associativity, the things will not change. Things will still remain the same. Hence, I simply regrouped it, because what I need is, I need something like this term. From the question, I have to see that I need something like A plus C plus E and B plus D. So that's what I did. Simply regrouped it and got here some kind of information. I'm getting that sum of A plus C plus E is 0 and B plus D is 0. That's it. Let's start using this P minus 1 is 0. Okay, I'll just simply, I need this. So what I'm going to do is, what we have with us is A plus C plus E plus B plus D is 0, derived from the fact that P1 is 0. Now we're going to use P minus 1 is 0. Let's see what I get from here. Replacing minus 1 in again Px, what do I get? A minus 1 raised to power 4 plus P minus 1 raised to 6. This goes on like this. Is equal to 0. Right? Factor theorem. Substitute minus 1 in the equation. Put it in this value, equate it to 0, and this is what you get. Simple. You just need to solve it. What I get is A. Then what I get is, okay, this has to be minus B. This has to be C. This has to be minus D. And plus E is 0. So what do we see here? I'm getting A minus B plus C minus D plus E is 0. Okay? So what do? I simply regroup again. What do? I regroup again. So A plus C plus E and B and D goes together. Minus B minus D is 0. Looks, we are getting into something now. So what we do here is, we see that A plus C plus E minus B minus D is equal to 0. Okay, so we'll just take B and D that side, so that we get A plus C plus E is equal to B plus D, which actually solves half a part. this part has been solved here. A plus C plus E is equal to B plus D. Okay. Now what else do we need to prove? That A plus C plus E is also 0 and B plus D is also 0. So how do we know that both of them have to be 0? From this equation 1. What do we see in equation 1? That the sum of A plus C plus E and sum of B plus D is 0. And both of them are same. That is, tell me a case. When is it possible that the sum of two same numbers is 0? What are two such numbers which have the same magnitude but they sum up to 0? When is that possible? Just take any whole number, any natural number. If you add it to the number itself, when will you get 0? The only possible case is if the number itself is 0. Right? Hence, what we say is, since A plus C plus E plus B plus D is 0, therefore, and also we just saw that A plus C plus E and is same as B plus D. Therefore, the only possible solution is which satisfies this condition is A plus C plus E is equal to B plus D plus E is 0. Okay? So, that's how we solve it. You saw how we used factor theorem and A square minus B square to solve this given problem. Okay? So, we'll meet in the next video and take up another such question. Okay? Thank you.